Hello, programmers. This presentation covers memory allocation in C and C++. Memory management is one of the functions of an operating system for controlling and coordinating memory usage. There are two ways memory is allocated for storing data. Memory can be allocated when the program is compiled, or memory can be dynamically allocated when the program is run. The operating system sets aside several sections of memory when a program is run. An executable file is created when the program is compiled. The executable part of the program contains both the code for the program and literals, constants, global, and static data. The stack is considered temporary storage that is used by functions and subroutines to hold the parameters passed to a function when it is called, the return address, and any local variables. The return address provides a way for the program to find its way back to the part of the program that called the function or subroutine. Memory locations on the stack get reused when a function or subroutine returns back to the part of the program that called it. Those memory locations are no longer needed for the local variables or return address and are made available for use again on the stack. The heap is also known as free store. It is used for dynamically allocated memory. When a program is running, it can request additional memory from the heap. Here is a chart that summarizes the two ways memory is made available to a program. When memory is allocated at compile time, memory for named variables is set aside by the compiler. The exact size and data type must be known at compile time, including for arrays. Memory allocated when the program is being run is called dynamic memory allocation and is usually placed in a memory segment known as the heap or free store. Dynamic memory allocation is done when the program does not know in advance the exact amount of space or number of items that are needed. When memory is dynamically allocated, the program receives the address of the first byte of memory. Since we are working with memory addresses, we need to use pointers. When a program declares a variable, enough memory is allocated to hold the data for the variable. Examples: int value, double price, character message, open close square bracket, equals, quote, enter a number, quote, int scores, open square bracket, 10, close square bracket. In these cases, the size of the variable or array is known when the program is written and compiled. When the amount of memory is not known, memory allocation allows the program to grab as much memory as it needs without needing to set aside a big block of memory just in case it might be needed. When the program is done with the extra memory, it needs to be returned back to the operating system so that other programs can have access to the memory that is no longer needed. Look at this code. The program's asking how many students and then attempting to declare an array for the number of students identified by the cin statement. This will not work. The size of the array must be known when the program is compiled. If the number of data items or the size of an array is to be determined when the program runs, memory must be allocated dynamically using the new operator in C++ program or a call to the malloc function in the C program. C++ uses the new operator to allocate memory from the heap for a single data item or object, or it can use the new open close square bracket operator to allocate memory for an array. The delete and delete open close square bracket operators return the memory back to the heap. The C language uses the malloc function to allocate memory from the heap and the free function to return memory. Malloc stands for memory allocation. Although malloc function still exists in the C++ language, it is recommended that the new or new open close square bracket operators be used because they not only allocate memory, they also construct objects, which is one of the main purposes of C++. Here is an example in C++ that shows how to allocate memory for a single data item. The C++ new operator is used to set aside enough memory to store a single integer. Upon successful allocation, new returns the address of the memory that was reserved. The memory address of the allocated data must be stored in a pointer. In this case, a pointer to an int named score pointer is declared. Int star, SCORE, PTR. In C++, memory is allocated using new int, which returns the address of the memory that was allocated. The memory address is then stored in the pointer variable named score PTR. This could be done with a single line instruction instead of two lines. Int star score pointer equal new int semicolon. If we want to set the contents of the newly allocated integer to 20, we can use star score pointer equal 20. Star score pointer to dereference the pointer to access the actual memory location. To cout less than, quote, the score is, quote, less than, star score pointer statement displays the score is 20 by using star score pointer to dereference the pointer and retrieve the 20 from memory. The allocated memory needs to be returned back to the operating system using delete score pointer. In C++, you can also initialize a variable at the same time memory is allocated for it. We can combine all three lines of int star score pointer equal new int, star score pointer equal 20 into int star score pointer equal new int open parentheses 20 close parentheses. Allocating memory in C and C++ is very similar, except in the C language the malloc function is used instead of the new operator. In this example, the malloc function is used to set aside enough memory to store an integer. Upon successful memory allocation, malloc returns the address of the memory that was reserved. Again, the memory address of the allocated data must be stored in a pointer. In this case, a pointer to an int named score pointer is declared as int star score pointer. All malloc knows is the amount of memory that needs to be allocated, not the data type. This example shows malloc being used to allocate enough space for a single integer. It is written as malloc, open parentheses, size of, open parentheses, int, close parentheses, semicolon, where size of int identifies the number of bytes for an integer. Since the data type is not known, the return data type for malloc is void star, meaning a pointer to an unknown data type. The open parentheses int star close parentheses cast operator in front of malloc is used to cast or change the data type to an int pointer so that it can be stored in score pointer, which is also a pointer to an integer. This could also be done with a single line instruction instead of two lines. Int star score pointer equals open parentheses int star close parentheses malloc open parentheses size of open parentheses int close parentheses semicolon. If we want to set the contents of the newly allocated integer to a 20, we can use star score pointer equal 20 by using star score pointer to dereference the pointer to access the actual memory location. The printf score equal %d, quote, star score pointer statement displays the score is 20 by using star score pointer to dereference the pointer and retrieve the 20 from memory. The allocated memory needs to be returned back to the operating system using free open parentheses score pointer. Allocating memory for an array is similar to allocating memory for a single item, except in C++, the array notation of open close square brackets is part of the allocation. In C, you just need to multiply the size of the data item by the number of items in the array. Since the name of an array, or in this case, the allocated array, is the address of the first byte of the array, We don't need to use pointer notation when accessing the array itself. Here, the name of the array is buffer. Individual elements in the array are accessed by using array notation and an index value. Buffer sub index. To get the third element in the array, we use buffer open square bracket 2 close square bracket, remembering that array indexes start with a 0. C++ needs to identify that an array is being returned to the free store heap by delete open close square bracket buffer semicolon. C does not need to know if memory was allocated for an array or a single item. In C++, an exception is thrown if there is not enough memory available. If you don't catch the exception, the program is terminated. You can prevent the exception from being thrown by using no throw as part of new, but then you need to process possible errors. Here is an example. Buffer equal new open parentheses no throw close parentheses int open square bracket 10 close square bracket. If buffer equal null pointer, cout not enough memory, else do something with the memory, delete the buffer, whatever you want to do. Dynamic memory is kept on the memory heap, also known as free store. If programs keep requesting memory from the heap and do not return the memory when done using it, the program may crash, or other programs that need dynamic memory may crash, or even the system may crash or give a message running out of memory. This is called a memory leak. The heap has a limit on available memory after the operating system and programs have loaded. Some operating systems also support virtual memory, but even it has limits. This ends the introduction to memory allocation and dynamic arrays. Another presentation needs to cover working with records, or the struct statement, and objects. Bye for now.